start with real numbers. What's the symbol for real numbers?
R and then another thing.
Yes.
IR.
Yeah.
Yeah, it's like double R.
Double R. I don't know why they put the double R, probably just so you don't think it's just an R. I don't really know. But I also don't think that those are original because this was all done in like Arabic and stuff at the very beginning. So they just Americanized it a little bit. Real numbers. How are real numbers broken up?
Into whole numbers, right?
Whole is in here, but it's not next. The subgroup of real numbers. It's either this or this.
Oh, real numbers and rational numbers. Nope.
Rational.
Rational and irrational. Which one goes here? Which one has more subgroups, rational or irrational? Rational. So rational goes here. What's the symbol for rational? No, R is real numbers.
Oh, one R instead of double R?
Nope, they're all double.
Oh. Okay, that's very
I know. It's okay. It's algebra 1.
Oh, man.
Yeah.
Wow, this takes me back.
Good. Good memories or bad memories?
I have to do.
You have no memories. That's even better. I'm just going to tell you. It's a Q. Oh, I remember now. Yeah, it's a Q. Oh, you don't? Good. That's even better. So rational is Q. Then we've got the irrational numbers over here. What's the symbol for irrational? No.
I.
No.
It's a Z.
No.
I'm not even joking with you. And it's one of those little weird things.
It's a letter.
And it's at the end of the alphabet.
No, it's not at the end of the alphabet. Did you say pi? Pi is an irrational number, so I'll put that here. But pi is a Greek letter. We're looking for American letters. Z is integers. We're doing really good. R can't be real numbers and irrational. What? Oh my goodness. I'm just gonna stop, y'all. It's a P. Okay, the mask. I can't tell. Oh my gosh. I'm sorry, Caleb. Okay. Irrational is P. What is an example of rational numbers? What makes a number rational? I know. The ACT is going to make you think. Online, if you guys know at any time, you can totally unmute and put everybody to shame. It's okay. 1 is a rational number. Good job. Okay. There are other ones other than 1.
2. 3.
Okay, yeah, 3 is good. What kind of decimals can I put as rationals?
The ones that stop.
The ones that stop, good. So I'm going to just put negative 3.5. That decimal terminates, so it is rational. Okay. I can also put what other kind of decimals?
3/5.
That's a fraction, but yes. So yes, repeating. So 3/5, I can put a fraction, or I can do repeating decimals. So like 4, 9, 4, 9 with a repeat bar. Those are also rational. Okay. So the difference between the two, a rational number is a decimal with that repeats. We'll do it that way. That repeats or ends or terminates. Okay. Can also be a fraction. So it can be a decimal, it can be a fraction, it can be 1, 2, 3, any kind of positive, any kind of negative. How do I make it irrational?
Well, like if it's just like a run-on number, like
Well,
if it's like,
this is run on 2.
well, like if it's not repeating like that.
You're right, it doesn't repeat. So the difference between rational and irrational, an irrational number is a decimal that never repeats, like pi. Okay, so this one is a decimal that never repeats. Okay. Now, the good thing about the ACT, The ACT is predictable. They don't change, okay? When I took it in high school, it's the same. Like, it really has not changed. The questions are the same. They just kind of filter them through. So the ACT likes to use the same irrational numbers over and over and over. They like to use pi, the square root of 2, and the square root of 3. Those are the most common irrational numbers that the ACT will use over and over and over and over again. So if you're used to seeing those 3 numbers, think irrational every time you see them. They expect you to know it because the ACT can be done without a calculator. The whole math section is designed to be done correctly, 60 minutes, 60 questions, none wrong, in, I don't mean to make y'all feel, bad for not being able to do it. But you can do it all without a calculator. That's the goal. Okay. I would use a calculator personally. Yeah.
Do people actually do that? Like take the ACT without?
Sometimes their calculator dies and you got to. I would, or they forget to come pick it up from me.
Do they like finish on time or like pass?
I mean, depends. I mean, it's not hard. Okay. It is hard if you don't know basic math facts off the top of your head, like the sine of 60. Like, they like to use that a lot. So,
What the heck is that?
like trig, the sine of 60 degrees. I don't remember what it is off the top of my head because I use a calculator. We'll get there. There's only 4 questions of trig on the ACT, so we'll be fine. But they like to repeat the same types of calculations. So when you notice them, you can kind of cheat the system. But it's okay. It can be done without a calculator. I would use one, but that's just me. Okay. So that's why they kind of repeat the same numbers over and over, just because you should know off the top of your head pi is irrational. All right. So it's a decimal that never repeats, and it can't be a fraction. Okay. Can't be a fraction. So this is kind of where irrational ends. And on page 2, we'll talk about imaginary numbers. But for right now, irrational is kind of stopped. From the rational side, we can subgroup even further. The further down you go, the more specific it gets. So what's the first subgroup of rational? Reals at the top. Whole's a little further down. These are all numbers. What?
Integers.
Good job, McKenna. It's integers. What is the symbol for integers? It's not I. Huh?
Z.
It is Z. I did. Good memory. All right, so it is Z. How did I write that? I wrote the letter Z and then I just did another tilted line. Do you want me to do it again? All right, here we go.
So,
Z.
That's
It's okay. We can all.
you have the value.
What?
You have the value.
Writing numbers and letters. Okay, I'll do it again. There you go. Here you go.
Why do they all have like double bars?
Good question.
So that we don't mistake it as a Z.
Yeah, like a variable. It tells you it's not a variable by making it capital and double barred. Yeah. So that way you can't be like, well, I thought that was a variable. They're like, no. What is an integer?
A number on a number line.
A number on a number line. Good job.
Really?
But all numbers are on number lines, so break it down a little further.
Negative and positive numbers on a number line.
That's all.
That's still all numbers.
From 0.
That's what absolute value is. Good job.
There's still decimals in it too.
There are. It's okay.
There's something to do with positive and negative.
It does have to do with positive and negatives, but what's the exclusion? Fraction 0? One of those is right. Integers cannot be fractions. Everybody knows that. You're right. Huh?
So it can't be a decimal.
Right. No decimals. So like -1, 0, 450. Those are integers. No decimals, no fractions. Now, 20 over 5, is technically an integer because when you do 20 divided by 5, it's 4. So just keep that in mind. It's just no decimals. So integers are no decimals. Okay. They can be negative. It could be 0, or it could be positive. Okay. So what happens from rational down to integers, we kick out the decimals. So now we can only have numbers with no decimals. The way that the ACT will trick you is they will try to make integers hard to understand because that's what they're paid to do. Okay? So you'll see a question that has a number line. If I wanted to put integers on this number line, what would I do? So think like if I'm like shading, do I shade all of it if I want to just show integers? Okay. What?
No, you don't.
I would put filled in dots. Where would I put them? On the numbers. So the way the ACT will test you is they will give you a number line that looks like this. And it will say what type of numbers are shown on this number line. It's just integers because they're not in decimal form. They're just -4, -3. When we graph inequalities, like greater than, less than, like things like that, we're going to do that on page, we're going to do it on page 7 and 8. We're going to do inequalities. So the ACT will make it hard by taking numbers and instead of listing them, they just put them on that number line because they want to freak you out. But you can still do it if you know what an integer is. Okay, what's next?
Real numbers.
No, that's
They're all real numbers. Real numbers are at the top. Whole numbers. All of these numbers are real numbers, okay? You're welcome. You don't have to keep saying it over and over. All right, what's the symbol for whole numbers?
A 0. I mean, no.
What?
Sorry, a circle? Is it an O?
No.
It's W.
It's W, yeah. Okay. Okay, I'm going to draw it slow.
This actually makes sense because it's whole.
First, I'm going to put a W. Have I lost y'all yet? Okay. Oh my goodness. I'm going to just put this little rectangle to the side. I believe in all of your ability to do this.
This is like the only one that matches. Like whole.
Yes. What are whole numbers?
They start with 0 and they go all the way.
Infinity.
They start with 0 and go to infinity, but what can I not put there? Decimals or negatives. So notice as we kind of go down this chart, first thing to go is decimals. The next thing to go is negative. And then something else is going to drop off the end in a second. So we've got 0. I should have put a 1 there. We'll just count by 0, 2, and 4. But yeah, it goes on forever. So no decimals. Again, decimals have been kicked to the curb. Now our numbers start at 0, and they can be positive. So no negatives. So if I wanted to show whole numbers on my number line, how would I do that? Yeah, I'm going to go 0 up. And I'm just going to put circles, closed circles here. On your first chapter test, I give you a question like this. It's right off of a practice ACT test. It's a very easy question. Remember, half of the test is just knowing definitions. You can hit benchmark if you know your definitions. This is the type of problem with these number lines that you might miss because you overthink it. They're just showing you numbers in a different way. It's not anything harder than me saying 0, 1, 2, 3, and 4 are what kind of numbers. They're just putting it on a number line instead. Same level of difficulty. Okay. What's the last group?
Give us the starting letter.
N.
Natural.
Natural.
Yeah.
Good job.
I was gonna say.
What's the symbol?
It's N.
It is N. Okay, ready? Write the letter N. Then I'm just gonna extend it. I believe in you to do this. Maybe this is easier because I did bubble letters in the 90s when I was a kid. And you all are like, no bubble letters. That's what it is.
Oh, I used to sell those things.
When I did a bubble letter, like that's hard.
As the bubble letters, yeah, they are hard. All right, where do natural numbers start?
1.
1. Natural numbers are also referred to as what type of numbers? Do not say real. They are whole numbers, but we call these counting numbers.
Oh.
Because if I say count to 10, you start at 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't start at 0. So these are referred to as counting numbers. Because when you count, you start at 1 if you're counting up. Again, no decimals. Okay. And these numbers can only be positive. I'll get a finish. Okay. All right, so these are all of the numbers. Now, when you classify, you go up. So the number 3 can be classified as natural. It's also considered a whole number because it meets that criteria. It's also considered an integer. It's also considered a rational number and a real number. So when you classify numbers, you work backwards. Okay. For example, if I give the number -1, what do we classify -1 as?
An integer, a rational number.
Yep.
And that's no, it's not it. Yes.
And a real number. So it's integer, rational, and real. So when you categorize, you go up, okay, because it meets each qualification. So let's do some operations involving rational numbers. So the way that the ACT makes this difficult for you is they give you a problem, but they take the numbers away. And you hate problems like that. For example, the problem could say, to make it easy, 2 + 2 equals what kind of number?
4.
Okay, what kind of number is,
That's a whole number.
okay, think even odd first. Let's do that. So 4 is what kind of number? Even or odd? Even. The way the ACT will do this is they will say A and B are even numbers. What is A + B equal to? An even number. But you panic sometimes because there's no numbers there. It's just letters, and you're like, I don't know what to do. So as long as you understand the theory of numbers, you can do hard problems that are not hard, okay? They just seem hard. So let's talk about rational and irrational numbers. A rational plus a rational, and you can use Q if you want to. You don't have to write rational out if you don't want to. It's up to you. But if I add a rational number plus another rational number, what outcome will I always get? A rational number. If you're unsure, you can always plug in an answer. You could say, okay, 1 + 2. Those are both rationals. I add them together. I get a rational number of 3 out. So just because you take the numbers away, you can still use their meanings. So this, 1 + 2, just plug in a number. Okay, what about a rational times rational? It is still rational. So when I multiply rational numbers, I get rational numbers out. Okay. It starts to get tricky when you throw irrational numbers in there. So an irrational plus an irrational. It is still an irrational number. If I add this infinite decimal plus another infinite decimal, I'm not going to get 2. Okay, it won't be infinite then. So irrational plus irrational, and this would also work for minus, plus or minus. Irrational plus irrational is also irrational. And it sounds kind of silly to like talk about that. It's like, well, obviously. But when you get to the ACT and you look at that practice problem and there's no numbers and it just says A is rational and B is irrational, what is the outcome of 2 plus A plus B? You freak out because there's no numbers besides the number 2. But it's really just rational plus rational plus rational. Okay? All right, the very last one is a rational times irrational. It is irrational. So once you throw irrational into the mix, you're not getting back to a whole number when you're multiplying. Okay? So down below, we've got 1 through 5. Go ahead and classify them as many ways as you can. You can write the letters or the letter symbol or write it all out. It doesn't matter to me. Okay. Do you guys have any questions online? Any clarifications, anything at all? Okay. I'm going to put this up for you. So go ahead and practice those 5. No, any order is fine. So you can put Z first and go from there. I just always start at the most specific and go backwards. So number 1 is basically everything. Number 1 is natural, whole, integer, rational, and real. 2 is rational and real. 3 is whole, integer, rational, real. 4 is irrational and real. And then 5 is integer, rational, real. How do we feel? Is it coming back to us now? It's okay. That will happen a lot in this class because you'll forget things and you'll be like, oh, that's all I do? It's okay. I'd rather you have that feeling now than on the ACT. Do you guys have any questions online? We're good? Okay. All right, we ready to move on to the world of imaginary numbers? Okay, so it is a lowercase I. Good job. You make fun, but you know. All right, so let's move on to imaginary. So we're on page 2. So we've talked about real. Now we're hopping over to imaginary. And we're going to learn some shortcuts, hopefully. This is an Algebra 2 topic, and I don't know, did you all learn this before?
Yes, a little bit.
Okay. Imaginary numbers, your calculator, when you have the TIs, you can change the mode to imaginary, and it will do imaginary numbers for you. I'm assuming the TI app will do it as well. So if you downloaded Wabbit Emu or Calculator X or Calculate 84, it will do it on there as well. So what is an imaginary number? How do I get what's an example of an imaginary number?
Negative square root of -36.
Yes. Good context clues. Any square root of a negative number, you were told in Algebra 1 it was impossible to do because they don't think that your brains can handle that at such a young age, that a number can be imaginary. So an imaginary number is basically when you're square rooting a number and you're square rooting a negative. Okay? You can still take the square root of a negative, but you have to move out of real and into the world of imaginary. So an imaginary number is a complex number. It's a complex number. That can be written as a real number multiplied by I. So the little I, it's a lowercase I, it stands for imaginary. So It's just an imaginary number. Now, if your calculator is not in imaginary mode, if you try to square root negative 36, it gives you error. It's like not possible because your calculator works in real numbers until you tell it to work in imaginary numbers. So the way that you get to an imaginary number on your calculator is you go to the mode. Okay, so if you've got your app on your phone, you can use that, or let me close out of this. Oh, the glare is so bad on this thing. It's so hard to film. There it is. So you press the mode button, and down here it says real. You want to move it over to A plus BI. A plus BI. So mode, and then go down to A plus BI. Huh? Yours automatically does it? That's good. And then you're done. Now, you can type regular old real numbers in imaginary mode. It's not going to mess you up. So you can keep your calculator in imaginary mode all the time. It's not going to affect it. It's kind of like when you do trig, like SOHCAHTOA. You can keep it in degree mode all the time. It's not going to mess anything up. So it can be imaginary and still work. Okay? So how do we get, what is the square root of negative 36? 6i. How do you get that? I know that you know it, but how do we know it? How do you break up the square root of negative 6? Or square root of negative 36? Okay, so I've got the square root of 36 times what square root? Negative 1. So the square root of 36 is 6. The square root of negative 1 is I. So you can do all these imaginary numbers as long as you just know what square roots are, like perfect squares. So just to pretend like the negative isn't there for a second and just do the square root of 36. It's 6. Then you just put I on the end. Okay? You can do it without a calculator as long as you know your perfect squares. Okay? So if I were to give you the square root of negative 25, what do we get here? 5i. The square root of 25 is 5. The square root of negative 1 is I. That's it. As long as you know perfect squares, you don't need a calculator to do it. So let's talk about the rules of I. Do you remember talking about the rules? Yeah, you can kind of use the clock if you want to. I'm going to teach you the best shortcut ever. What is I to the 1? I to the 1 is I. Because anything to the first power is itself. Yes. What is I squared?
I times I.
It is I times I. So what is I times I?
2i.
No.
I squared.
It is already I squared.
Wait, so I squared 1, so 1. Is it 1, 2?
You know the online.
Yeah, the online people are like, what in the world is going on in here? Okay, let's break it down if we don't know. It's totally fine. I'm not going to publicly shame you. Just privately. Okay. All right, so I squared. What does I represent? An imaginary number. Let's think of it in terms of square root.
Wait, it's I squared negative 1.
It is. Good. I cubed. Let's make it harder. I know. I believe in you. You're welcome.
That's 1.
No.
0.
No.
2.
Ooh, okay. It's negative I.
Wow.
I know.
Oh, so it just goes I negative 1.
Oh, it's coming back to us. What's I to the 4th? Good. It's not going to be any kind of 2. It's either going to be 1 or I and a combination of negatives.
It'd be 1i.
Just 1.
Great.
Okay. It's okay. You guys were like in quarantine when this was probably taught to you. We'll just use that as the excuse.
Yeah, I can see that.
Yeah. It's Corona's fault.
My teacher wasn't there to teach us it because he was out for surgery.
Yeah,
okay.
Mr. Roberts.
I will teach you. Okay? We can do this. Now, after I to the fourth, it repeats. So it repeats every 4 terms. So what's I to the fifth? I to the sixth, -1. It just repeats every 4. Are we okay? We know what repeat means? All of you look really scared. So basically every 4 it repeats. We understand that? Okay. I'm going to teach you a trick. We want to know what I to the 525 is. We look at the last number, which is 5. So it's I. Feeling confident? Good. Okay. That's okay. The last number here is 5. So I'm just going to count. 1, 2, 3, 4, 5. Done. It repeats every 4. So as long as you know the first 4, you know all of them. Yes.
Okay, so if it's still I, then what's the point of the 525? Why not just put I?
To test your knowledge of I. That's honestly all it is. It's for the ACT to know, do you understand how to use I? That's all it is.
So that could be any number, and it's still going to equal one of those 4.
Yes, it repeats every 4. So I to the 23, what's the last number? 3. Yeah, 1, 2, 3. That's all you have to do.
So for 8, it would be 4.
Mm-hmm.
So then 1.
Yeah. So for 8 is the last number. You could count 1, 2, 3, 4, 5, 6, 7, 8. That's it. Okay, I to the 26. There you go. 1, 2, 3, 4, 5, 6. Done. As long as you remember the first 4, you're good. You can do all of them. Now, one thing that I want to make sure that you know is if you have doubt and you don't remember, you have a calculator. Just use it. Type it in. I to the 5. It'll tell you the answer. Most of the time, it will do all of them. However, some of the bigger numbers, it'll like clog your calculator. But if you can't remember the first 4 iterations of I, all you have to do is in your calculator is do I to the 1. It will tell you what it is. You can build the 4 to get there. And McKenna, no, the other numbers don't matter, just the last one.
So all I probably just do okay.
For the most part, yeah. Which is good. Okay? But your calculator has to be in imaginary mode for it to accept it. So if you typed in I to the 5th in your calculator and it's in real, it'll say not possible. So you have to change your calculator's frame of thinking. Easy enough? Good. That's all there is to I. What's an even number? Okay, 2, 4, 6, 8. What is, so numbers that are 2, 4, 6, 8, what number are they all divisible by? 2. So an even number is divisible by 2. So the term divisible means if I divide it, I don't get a decimal. So I can, when I do 2 divided by 2, I get 1. 2 divided by 4, or 4 divided by 2, I get 2. So no decimals. What's an odd number? Not divisible by 2. Good job. Yeah, it's just not divisible by 2. All right. Now, the ACT loves even odd questions because they can give them to you without giving you any numbers. They just say A is even and B is odd. What is the outcome? Okay. Yeah. So let's go through all of them together because they're not hard problems. It's just you have to think in terms of abstract. So it's going to take away numbers from you, but it's going to give you definitions in its place. So let's practice. I'm just going to write O and E for even and odd. So an odd plus an odd. What kind of number will I always get? An even number. An odd number plus an odd number is always even. You can test it. 1 plus 3 is 4. So if I add an odd number plus an odd number, I always get an even. Okay. What about even plus even? Yeah, even plus even is still even. 2 plus 4 is 6. Just test it. Okay. Understanding numbers without numbers. That sounds so weird to say. But knowing numbers without numbers makes this a whole lot easier. If you can think in terms of even, odd, you can do all of these problems that we're going to practice. So what about odd plus even? That's an odd. 1 plus 2 is 3. 3 is odd. Okay. What about odd times odd? It's odd. 1 times 3 is 3. So it's an odd. Even times even. Even. 2 times 4 is 8. And then last one, odd times even.
Odd. No.
Just pick an odd number and an even number and multiply.
1 times 2 is even.
It's even. Okay. You can do all these problems. You just have to pick a number. As long as you know the definition, you can do these. It just is going to take some getting used to thinking about problems without numbers. Okay. The ones where we epically fail is prime and composite. Because you tend to think that all prime numbers are what? All prime numbers are odd. That's what your mind always goes to. But that's not true. Okay? What's the smallest prime number?
3.
Mm-mm.
7.
Mm-mm.
0.
Mm-mm. 2.
Oh.
So prime numbers, you'll get tripped up because you forget that 2 is prime. Because you think, oh, 2 is even. You correspond even and prime to be opposites of each other. Like only odd numbers can be prime, which is not true. So a prime number is a whole number whole number greater than 1, so technically it's a natural number. So it's got to be bigger than 1. Whole number greater than 1. Whose only 2 factors are 1 and itself. Now, we don't include 1 because it has to be a number other than 1. Okay. So the smallest prime number, where the only 2 things that divides evenly into it is other than 1 and itself, is 2. 2 is the only prime number that is even. All other even numbers are composite, but you will miss it because what's going to happen is on the ACT, it'll give you a list of numbers. It'll say what number set contains only prime numbers. And you're going to have an option with 2 in there. And your brain is going to think, oh, 2 is even. It can't be prime. But they're trying to trick you. 2 is the only even prime. So it's the only even prime number. Knowing that little tiny fact is the difference between getting benchmark and missing it by one question because you don't know what a prime number is. So 2 is the only even prime. What's the next prime number? 3. Then what? 5. 7. What's next?
9.
11. 13. Because we think prime means odd, and it doesn't. It means not divisible evenly by 1 in itself. That's it. Okay. So the next one would be, no, not 15, 17. Okay. And then it kind of continues from there. So not all odd numbers are prime. So we're going to practice multiplication facts, doing those timed multiplication practices from when you were like in 3rd grade, where I put the timer on the board and give you a bunch of pressure. All right, composite numbers. What's a composite? The opposite of prime, basically. So like 9 is a composite number. Why does 9 not classify as prime?
Because it's different.
3 times 3. I have another group of factors that I can multiply to get 9. For 2, I can only do 1 times 2. That's the only thing I can multiply to ever give me 2. But 9, I can do 1 times 9 or 3 times 3. So a composite number is a whole number greater than 1 that can be divided evenly by a number other than 1 in itself. So just by clarifying all of these definitions, it's going to make this a whole lot easier. It's going to make the problems that you would probably skip on the ACT ones that you can do. Because these people are paid to make easy concepts difficult. So we're going to fix all that. I'm going to tell you all the tricks. Okay. So what is the smallest composite number? What? 4. Composite numbers start at 4. Can't be 3 because I can only do 1 times 3, and 2 is also prime. What's the next one? 6. Next. 8, yeah. 4 times 2. What's next? No. 9. 3 times 3. Then what's after that? Not 12. 10. 5 times 2. Now it's 12.
Oh.
Then it's 14. Then it's 15. Good. 16. Notice how it's basically filling in the blanks of the prime numbers. So like prime, I go 2, 3, 5. Well, the 4 fits right here. So they just kind of fill in the blanks. Okay. All right. Online guys, are there any questions about classifying? Okay. Do you have any questions on how to access the worksheet and how to upload your work? No? Kayla, you look confused. Do you have a question? You can ask me. You can unmute your mic and ask me. It's okay. First page, yes. Right here. Okay. Kayla, do you have a question?
Yeah, you put taking down the composite.
Mm-hmm.
And
Okay, 15 is composite because I can do 3 times 5.
Okay.
Yep.
Okay.
Yeah, it's hard because the odd numbers, sometimes you think odd with prime, but you can have odd composite numbers as well. It's tricky.
Well, I was confounded by 2. So,
Oh, yeah, that would make it odd versus even.
yeah.
Yeah, that's okay. Any other questions? Okay, so your homework for tonight, or actually, you don't have to work on it tonight. Tomorrow during class, while I give out the paper worksheet to my kids, you guys are going to work on the form worksheet during class. So you don't have to do the classifying worksheet now. You can do it tomorrow during class so I can answer questions. If you've already done it, that's totally fine. You can go back and relook at some of the questions if you have them. If not, I still need you to just log on tomorrow. But if you've already done it, I can answer some questions. Does that work? Okay. Is this what you need, Ashton? That? Okay. Any other questions? Okay, so online guys, I will see you all tomorrow. Bye. Have a good day.